Hello, my name is Dr. Maying Boon and I'm a lecturer at the School of Optometry and Vision Science. So optometry is essentially the clinical side of understanding how we see, how we process vision, and also about how light produces an image in our eyes, which we then process in the brain. And also, I guess, working out ways to solve vision problems. Vision science is the science underlying all of that, where we understand how we see the world. The highlight of my career is being able to talk to other scientists who are at the cutting edge of the field about all the new developments in science and working out new ways to analyse the visual system. When I graduated, I was a clinical optometrist, and as part of a clinical optometrist, we see patients and try and solve their visual problems. And it got to a point after several years where I realised that very often I'd be answering the question with, we don't know the answer to that yet, or the scientists still need to understand that better, or before we have a cure. So I eventually thought, well, I'd like to be a part of the solution, and so that's what drew me into research. My opinion of maths has changed quite a lot because I guess the practice of it has changed. So when I was in school, I felt it was a lot about logic and proofs, and now I see that maths is actually everywhere and it's given me a different way of viewing the world. So it allows me to see patterns which might be hidden, which are not necessarily on the surface. And especially being a vision scientist, we tend to see very much the world in terms of 3 dimensions, plus 1 dimension in time. And so it's really good that maths allows us to access what is hidden and the higher dimensions in the world. So I think it's a very useful way to see the world, and the more I learn about maths, the more I realise that it's everywhere. I do quite a lot of different types of research projects, but one particularly interesting project is where I measure how the visual system processes visual images. So light hits the retina in the back of our eye, and then that gets transmitted by electrical signals to our brain, and I record how the brain responds to those that stimulation. And the very interesting thing is that even though we may show the same picture or image to the eye several times in a row, our brain doesn't respond exactly the same way. And so if it responds in a sort of sinusoidal way, we may use a technique called Fourier transform, as you can see on the screen, to break it down into sine and cosine values and then measure the amplitudes and phases that way. Another way you could look at it is to see that perhaps this is a chaotic system because it's not exactly the same every single time. There's a little bit of randomness in it. And so, as you can see on the screen, I then use the Grasberger and Procaccia algorithm. And the good thing about this algorithm is that it allows us to measure the dimension of the system which produced the brainwave that we recorded. In the Optometry and Vision Science course, we do use MATH1031 topics quite frequently. So one area is when we're trying to distinguish between what is a normal and an abnormal reading. So for example, we might have measured the eye pressure in a person's eye, and you want to know, is this number actually a normal value or not? And so we would do curve fitting over a lot of people who we know are normal, and the curve that we usually get is called a bell curve. And so if we find that you take an individual measurement and it's outside that bell curve, so more than 2 standard deviations above or below, then we could say this patient is likely to be abnormal. So that's one way we use maths in optometry. We also use it to monitor over time. So you might have a patient coming back several times, maybe once a year for 10 years, and you can observe trends over that long period of time, which is a type of curve fitting as well. Sometimes we don't wait so long. We might measure several times during the day. So for example, with the eye pressure problem, we may measure it in the morning, lunchtime, and then we'd get probably a sinusoidal curve, and we would use trigonometric functions to try and understand, is this a normal response, like are we getting expected curve or are we getting an abnormal curve? Also in optometry, we definitely use a lot of statistical techniques which relate to change over time, or change of one parameter with another, which is what we'd call, I guess, calculus or differential equations. The best memories I have for studying as an undergrad is really the study groups that we formed. So, for example, I had a very good friend who helped me out with biology, and I helped her out with physics, and we learned together, and I think that's what happened all the way through uni, and I really enjoyed that.